Hello friends, I am Chandan. Today's topic is representation of various process on PV diagram. Now suppose PV to the power k that is equal to constant. Here if k equal to 0, then you can say that p equal to constant, because v to the power 0 that means 1, that means p is equal to constant. If k equal to 1, if you put this here k equal to 1, then pv that is equal to constant, that means it is a isothermal process. Okay, pv equal to constant. Now if k equal to gamma, it is pv to the power gamma that is equal to constant, that is adiabatic process. If k equal to n, that is pv to the power n that is equal to constant, that is a polytropic process. And if k equal to infinity, v equal to constant, that means it is a constant volume process or isochoric process. Now if you see on, suppose consider this is a expansion process. So suppose just focus on this graph. Here v is on the x-axis and p is on the y-axis. Suppose if k is equal to 0, then that means if k is equal to 0, that is a constant pressure process, so that means this process, suppose this is the initial point, this is 1 is the initial point and this is the 2. So here the process will be from this to this. So k equal to 0, this is a constant pressure process. And if k equal to infinity, then v equal to constant, so the process will be in that direction, that is downward direction. So this is constant k equal to infinity. And from here k equal to 0, k equal to 1, if k equal to 1, the process will be like this. And if k equal to n, that means polytropic process, the process will be like this. And if it is a adiabatic process, the process will be like this. Okay, now if it is a compression process, this is the, here this is a volume axis and this is the pressure axis, and this is the initial point 1. Now if k equal to constant, that means p equal to k equal to 0, that means p equal to constant. So this is the final state. So from 1 to 2, this is the uh, constant pressure process by isobaric process. Or if k equal to infinity, that is a constant. If k equal to infinity, that means it is a constant volume process. And if k equal to 1, the process will be like this. If k equal to n, the process will be like this. And if k equal to gamma, the process will be like this. K equal to gamma means it is a adiabatic process. Now next topic is that slope of isothermal and adiabatic curve on PV diagram. Just compare this slope on isothermal and adiabatic. We see that the adiabatic and isothermal curve on PV diagram are almost same. But now we have to calculate. We have to see that what is the slope actually. Now focus on the isothermal process. In isothermal process, this is the volume axis. This is the volume axis and this is the pressure axis. Suppose this is heat addition or heat rejection. This is any process. Now if remember that first you draw a horizontal line, and if the slope is clockwise from horizontal line, then it is a negative, and if it is a anti-clockwise slope, that is positive. Remember this is very important. If it is clockwise slope, that is negative, and if it is anti-clockwise slope, that is positive. Now slope, how to calculate this slope? Slope is basically calculate, that is equal to dp by dv. That means if you want to calculate the angle or slope, that is equal to dp by dv. Now for isothermal process, we all know that pv that is equal to constant. So from here you can see that pdv plus vdp that is equal to 0. From here VDP that is equal to minus PdV. From here dP by dV at t equal to constant, that is equal to minus of P by V. So this way there is a negative because there is a clockwise slope. So that is why there is a negative. So remember this formula, dp by dv at temperature T equal to constant, that is equal to minus of P by V. Okay. Now if it is an adiabatic process, then the slope, suppose this is the pressure axis and this is the volume axis, suppose this is the slope. So here there is a clockwise slope, this is the horizontal line, and there is a clockwise slope. So we know that clockwise slope are positive. Now if you want to calculate the slope, that Pv that is equal to constant, Pv to the gamma that is equal to constant, it is applicable, it is a, because it is a adiabatic process, so it is applicable P to the gamma that is equal to constant. If you derivative on that, P gamma V to the power gamma minus 1 dV plus V to the power gamma dP that is equal to 0. From here you can calculate the slope. So dP by dV at A is equal to constant, that means reversible adiabatic process is also known as isentropic process. So this is at that means here A is equal to constant means this is a adiabatic process. So dP by dV for an adiabatic process, that is equal to gamma times minus of gamma times P by V, minus of gamma times P by V. So here this is minus of gamma times P by V. Gamma is, we know that gamma equal to 1.4. We know that gamma is equal to 1.4. So here in the isothermal process, the slope will be P by V, minus of P by V. But minus is basically indicates that the slope is clockwise or anti-clockwise. Now here this is P by V, and for adiabatic process that is gamma P by V. So in that case we conclude that for adiabatic slope is greater than isothermal slope. So remember that the adiabatic slope here the adiabatic slope, this slope will be larger compared to isothermal slope. Now if you finalize this, then this is the pressure axis and this is the volume axis. Here suppose this is any one process and this is another process. Now here if you want to calculate the slope, here angle and here angle, so which angle is larger, this process will be adiabatic process, and which angle is less, that is isothermal process. And here suppose this is the expansion process, and here there is a compression process. The initial point is 1 and final point is 2, here also 2. Suppose this is the process, this is the process. Now if you want to calculate the angle, which angle is better, which angle is greater, this process will be adiabatic process. So here we see that this angle, this process angle is higher as compared to this angle. So we can say that this must be adiabatic process, and this process must be a isothermal process, because its angle, that means slope is less. Okay, so we can conclude that hence slope of adiabatic curve is gamma times greater than slope of isothermal curve on PV diagram. So this is my handwritten notes, you can download it from the description link. Please like, share and subscribe my YouTube channel, and there is a Telegram link, please join on that link. I will share daily one chapter wise notes, and all the video links are available on the Telegram group. You can join this group. Okay, thank you.